Uh, Thank you for having me. And today I will talk about the decentralized open source collaboration. I'm Quanyi from Huawei, and I'm also an independent member of the Web3 Infrastructure Foundation, which the foundation is established in Hong Kong last year, and the foundation is dedicated to support the open source project to build the Web3 infrastructure, and my work is on the open source collaboration infrastructure. Is crucial for the mission, and you can get me through the ID, Twitter, Gmail, or GitHub. So let's talk about the current situation of the open source collaboration. First, Git is the most popular version control system in the world. It has no central repository dependency, which means the developers has own complete and they can work independently. The architecture enables the distributed workflow, which is perfect for the distributed developer team. Since each developer has a full copy of the repository, they can work offline and make a commit, create a branch, and any performance of the version control system. They can synchronize their changes when he back online. And Git, the distributed nature allows for flexible collaboration modes. Teams can choose a central repository for coordination, but it is not stringently required. A developer also can choose work independently, share some changes with a subset of collaborator, or contribute to multiple repositories. So Git is the distributed version control system. Is a complete decentralized version control system. Now everyone using GitHub. GitHub is for the open source collaboration. GitHub is a very powerful platform. They have lots of features like the PR, like the issue, special the actions. Everyone uses the actions for there are lots of the free resources helping the developer build the open source project. But there is a very important thing is GitHub is the centralized service. It has much power over the open source project which is hosted on the platform. They can use all the data, like the training the AI, or even the delete some repository or account, or disable some countries using it. So GitHub is an enterprise service. Is always be the interest in is the shareholder. So how we build a decentralized open source collaboration? So we can think. I think it's a two-layer. First, we must have a data layer. We can extend the Git to use the distributed service. For now, we don't want to invent a new version control system. There already has some version control system written by the Rust, like the Sapling. Sapling is open source by the Meta. Is open source. Looks like rewrite the material with Rust. And there also has a pure Rust open version control system. Is Git Oxide. In the cargo already using the Git Oxide, but we want to invent a new one. So we rewrite the Git, add a middle layer. We rewrite a Git host service as the middle layer. Everyone can use the Git client to connect the Git host service, and the Git host service has the decentralized ability. So we build the data layer with rewrite the Git host service. It's named Mega. Is under the Web3 Infrastructure Foundation repository. And we also need a collaboration layer. We must let other developers know which repository open and which where there is the merge request or others. So we design event system and will be adapted to the Matrix, Nostr, or Mustang. So we think we should do the layer, collaboration layer and the data layer for the entire open source system layer. So let's discuss how to rewrite the Git for the decentralized service. First, Git is an addressable file system. Every file in the Git is a blob object. Wrapped the file contained in the blob object, and there is the Git share. The Git calculate the content for SHA1 value is identified the file where is it. So we use the blob object in the Git store all the files, and there is another objects like the tree objects is present dictionaries in the repository, and also has some other information like the commit message and author emails is stored in the commit object and tag object. So we rewrite all of this with the Git with Rust, and there's no way to get through the SH1 from the Git. It just is a command in the Git repository. But if we want to use in the decentralized network, so we add a URI. You can get the object through the SHA1 value. So it's for the decentralized network, we can get everything with SH1 value. And also Git and the Git service translate data with the Git pack is a special format with the version with the compressed. So if you pull from a Git service, you will tell the Git service which had SH1 the value, and the service will calculate what they should return to you, and compress all the object to a pack file to the client. So we rewrite the encode and decode all of this, and with Rust, so the host service can decode and encode online and stream. But if we want to use in the decentralized, we must add a new URI. Is the pack list. So if like this, if a client is a clone from the different service, first we ask the service A, I want to clone something, and the service A will return the object list with the SH1 value, and I will get a different object from a different service, so we can use as a decentralized solution. For the first version, we used libp2p and DHT, so we record everything in the DHT, and there is a JSON format, and we record where is the service like the peer ID and the repository name and the last commit value. So everything in the DHT, so every service of the Mega using the DHT recorder through search. But there is a very important problem is every service can change the DHT value. So if everyone uses the Mega service in the decentralized work, But also the hacker can compare the service by himself and change the value. So it's a very big problem. So we, in the next version, we choose another one, as we rebanding the libp2p and the DHT is the new decentralized network infrastructure, namely the ZTM. It's a zero trust mesh. It's a new open source project by my friend. Is a founder of the Flow Mesh, and he also the founder of the Web3 Infrastructure Foundation. They use the ZTM like the HTTP2 tunnel between the microservice. So we are working on this. We use the ZTM to replace the libp2p, and also we just export the HTTP service to the ZTM, and we don't care any the DHT. So we are working on this. I think we will be a new solution for the decentralized network. So let's talk about the design the events for the decentralized collaboration. In my first version, we use the Nostr event. So we make a Nostr SIP, so it looks like the Nostr event is using the tag. And if the ID is the service, the peer ID, and the A is the action. So if we update the repository, they will be broadcast event to the Nostr network. So I think we don't rebuild a new decentralized network. We just adapt the already exist decentralized social network with the collaboration. In the future, we are abstract the event, so we can adapt the Nostr, Matrix, and other Mastodon, any decentralized social network. Sorry. So we also write working on something is rewrite the Git LFS filter, and the server for the LLM is also for the large file system. We know is the LFS is the Git filter. When we commit, the filter will be checked which file should be recorded and move the LFS folder. And when we push to the server, the LFS filter will push the file to the another object service, OBS. So when we pull get something, it's all like that, all like this. But if we want to use in the decentralized, we couldn't ensure it's a file capabilities file. So we do something like this. We split the file to the large files to the piece or trunk and deliver with the decentralized network. So we get some URI like this. If we get the file, is usually we get endpoint file endpoint, but we also get a chunk list with the SHA 256, get a chunk hash value list, and we get the every chunk with the value. So we use this in the decentralized network, so we can use the decentralized network deliver a large file like the LLM. So for now, we are a service you should deploy with the PG, PostgreSQL database, and in the internet. And in the future, we are plan to build all of this using the Terry. We should be. We think it's be an application you can install your laptop, so you can use the application in your laptop and connect to each other without a service. But we also use a relay server like ZTM, and we have a plan to deploy some CTM anonymous and with the Web3 infrastructure foundation. So it's on the architect, and in the future will be release some application. Okay, that's all. Thank you.
Any questions for the decentralized Git?
Okay.
Small question, maybe not really strictly to Git, but did you consider deploying not just Git, but dependency management of projects?
What?
What I mean by that is that projects in Rust, for example, they have a cargo log file which specifies its dependencies based on hashes, right?
You means you have a lot of projects and a lot of files.
Log files.
Lot of files.
For the Rust project.
For us project, for
files.
Other projects as well. These log files contain hashes of dependencies of the project.
Okay.
And you could use these hashes to find the dependencies in the distributed network and download them, not from the centralized storage, but from the network.
Yeah. If we get some, if I clone from a decentralized service node, there will be return a file list with the SH1 value. Maybe if it's a large file, like the Linux kernel has 9 million files, yeah. So we get the list, and we from the different service get the object to the local.
Yeah, but the thing is, dependencies are not stored in the Git repository. They are downloaded from an external storage.
Yeah. We rewrite the Git store engine. We know with the Git store the file in the local system. Yeah. With the SH1 value is in the different folder. We rewrite the store engine with the circle. We store all of the information like the into the PG or circlet, so we can select something from get all of this result. I think you mean let's explain. It's in the Git with DAG engine is commit, so forward commit. The commit link to the tree link to the files. Yeah, it's the Git the architect. So we rewrite with Rust, install all the information into a database engine. So we know which the repository has the files, has the dictionaries. So we can use the circle, select something from the table. Yeah.
Okay. So if I understand correctly, it's mostly just about transferring the Git objects via P2P. When it comes to rewriting history, so if someone, I guess in this use case, you're talking about extremely large blobs, the information that's used for LLMs, I guess.
Yeah.
But if you were to rewrite history of a Git repo, you wouldn't be able to remove that from the peers, right?
Yeah.
So that would be a risk, but also it's the trade-off, I assume.
Yeah. So in our architecture, we looks like a Git compatible interface and object storage service like the OB, like the S3 Amazon. So you can get the object through the Git protocol like the SSH, HTTPS, and you also can get from our object services. So if we want to deploy in the internet, we will use the CDN host all those things. So you can get a chunk of the large files from the CDN or other service. So we will be write a balance engine, so get a different service.
Okay, that's great. Thank you so much, Quanyi Ma, and then